Japan spent nearly $12 billion building a seawall that stretches for 400 kilometers. In some places, it stands as tall as a 4-story building. It is so massive that families living behind it can no longer see the ocean from their own homes. But this wall was not built to show off Japan's engineering power. It was built because of what happened on the 11th of March 2011. People ran for higher ground. Some made it. Many did not. Families waited for loved ones who never came home. Every mile of this wall carries the memory of that day. And here is the part that should make you stop and think. This wall is taller, thicker, and smarter than the seawalls that came before it. It has sensors, reinforced foundations, and automatic floodgates, yet engineers still admit it cannot stop every tsunami. So what did Japan really build? A wall strong enough to fight the ocean? Or a massive machine designed to buy people a few more minutes to escape? On the 11th of March 2011, everything changed in just a few minutes. The ocean floor suddenly shifted, pushing an enormous amount of water toward Japan's coast. What followed wasn't just another wave. Survivors described it as a moving wall of black water. In some places, it reached nearly 40 meters high. It kept moving inland, destroying almost everything in its path. What shocked engineers the most came afterward. Around 90 of Japan's seawalls failed that day. But they didn't all fail because the waves smashed straight through them. In many places, the water simply poured over the top. Once it reached the backside, it washed away the soil supporting the wall. The foundation disappeared, and the entire structure gave way. Even the Kamaishi breakwater, once known as the largest of its kind in the world, couldn't survive. Then, one small village changed the conversation. Its taller seawall helped save roughly 3,000 lives. That single success proved something important. The answer wasn't just to build higher walls. They also needed stronger foundations, designs that could stay standing even after water flowed over them, and evacuation plans that worked together with the wall instead of relying on it alone. That became Japan's new way of thinking. And maybe that's the biggest lesson from 2011. The most dangerous part of a seawall isn't always the side facing the ocean. Sometimes it's the part you can't see. If the foundation fails, it doesn't matter how strong the wall looks from the front. Everything can come down in the end. One thing surprised me the most about this project. Japan didn't build one giant seawall and copy it for 400 kilometers. Every section was designed for the exact place where it would stand. If a stretch of coastline faced the open ocean, the wall was built taller. If it sat inside a protected bay, the height could be lower. Engineers looked at local wave records, the shape of the shoreline, and how the water had behaved in the past before making those decisions. And they didn't stop there. Before a single stone was placed, survey ships drilled deep into the seabed to find out what was underneath. Some areas were soft clay, others were dense sand. Some rested on solid rock. Each type of ground needed a completely different foundation. There was no one-size-fits-all solution. They also went back and studied every major failure from 2011. Instead of pretending the old system had worked, they wanted to understand exactly why it failed. In some locations, they spent months measuring and checking every single meter of coastline before construction even began. Then came another challenge. About 440 construction teams worked at the same time. If just one contractor stopped working or left a gap unfinished, the entire line of coastal protection could be weakened. Every section had to stay connected. The tide made things even harder. In some places, crews had only about 4 hours each day to work on the seabed before the water came back. Every hour mattered. Looking at the finished wall, it's easy to think this was one huge engineering project, but honestly, it wasn't. It was thousands of small decisions, made one after another, along every meter of Japan's coastline. And in the end, those small decisions are what made the whole system possible. Here's something I didn't expect. The part of the seawall everyone notices is actually the least interesting. The real work is happening below the water, where most people will never see it. In some areas, the seabed was so soft that heavy equipment would sink into the mud. So, before construction could even begin, crews laid down huge steel plates to spread the weight. It was the only way the machines could work safely. Then came the underwater foundation. Divers carefully guided 5-ton boulders into place. The water was often too rough and too cloudy to see anything clearly, so engineers relied on sonar instead of their own eyes. They had to trust the data because they couldn't always trust what they could see. Between those rocks and the fill material, they added a filter layer. It doesn't look important, but without it, seawater would slowly pull fine soil particles away. Over time, the wall would become hollow from the inside. A geotextile layer added another level of protection, keeping the soil where it belonged instead of letting it wash into the gaps between the rocks. Every layer of the foundation was compacted with incredible care. Even a small amount of uneven settling could tilt the entire wall above it. That's why they refused to rush this part. Deep below the surface, interlocking steel sheet piles were driven into the seabed to protect the base of the wall. Their biggest job wasn't stopping the wave coming in. It was protecting the foundation when the water rushed back out. That surprised me. The video explains that the returning water can actually be more dangerous. As it flows back to the ocean, it acts like a giant vacuum, pulling sand away from the foundation. If enough sand disappears, even a massive wall can lose the support holding it up. And that's probably the biggest lesson here. A seawall doesn't usually fail because it doesn't have enough concrete. It fails because of the small things people never notice. One missing filter layer, one rock placed in the wrong spot, or just a few inches of uneven ground underneath. Sometimes, the strongest-looking structure is only as strong as the details hidden below the surface. What really stood out to me was how little room there was for mistakes. Every layer of soil inside the seawall was placed about 300 millimeters at a time, then compacted before the next layer went on. If they dumped in too much at once, the machines couldn't compress the bottom properly. That one shortcut could weaken the entire wall years later. Between those soil layers, engineers added geotextile reinforcement. Think of it like steel rebar inside concrete. You don't really see it, but it's one of the things holding everything together. And they checked everything. According to the project standards, the fill had to reach about 98 Fun-Trum Proctor density. If it didn't meet that number, inspectors could stop the job immediately. There were no exceptions. Inside the wall, a compacted clay core helped keep water from slowly leaking through. Drainage pipes carried rainwater away before it could build up inside the structure. At one point, a single night of heavy rain caused part of a slope to collapse. They didn't patch it up and move on. They tore the whole section apart and rebuilt it from the ground up. That tells you everything about the mindset behind this project. Once the wall reached full height, crews began installing concrete panels weighing around 7 tons each. Every panel had to be free of cracks, free of air pockets, perfectly supported, and securely tied into the top of the wall with steel bars. If even one panel failed inspection, it wasn't repaired. It was crushed and replaced. The coastline wasn't straight either. So Japan didn't force straight panels onto curved shores. Engineers created about 37 different panel shapes using precision-made molds, so each section would fit tightly and leave almost no gaps. The more I learned, the clearer it became. This project wasn't about building something that was good enough. It was about removing every weakness they could find. Because when a seawall is protecting people's lives, almost past, still means it failed. One thing I finally understood is that Japan never expected this wall to completely stop a tsunami. That was never the real goal. Instead, they wanted to slow the water down, spread out its force, and control where it would go. That's why the protection doesn't start at the wall itself. In front of the wall are huge concrete blocks called tetrapods. At first glance, they look like they're scattered randomly, but every gap between them is intentional. Those openings let water flow through while breaking up its energy. Instead of slamming into one solid surface, the wave loses strength little by little. The size and weight of every tetrapod were carefully calculated based on the amount of wave energy expected in that area. And that's only one layer. Below the water, there are several lines of defense working together. A rock mound helps weaken the waves. Steel sheet piles protect the base of the wall. Tetrapods absorb more energy. Then, if there's still force left, the main seawall takes the impact. In some places, engineers even built submerged breakwaters about 200 meters offshore. The idea was simple: make the wave spend some of its energy before it ever reaches the coast. But the biggest lesson came from what happened in 2011. The old seawalls weren't destroyed only because waves hit the front. Many failed after water poured over the top and attacked the backside. That's why the new design includes drainage systems and extra erosion protection behind the wall, giving the water a safe path instead of letting it wash the foundation away. Even the top of the wall has a job. It's built with about a 10-degree angle, so overtopping water is pushed back toward the ocean instead of crashing straight into neighborhoods behind it. The more I looked at the design, the more I realized this wasn't about beating nature. It was about taking away as much of its power as possible. Because you may never stop the ocean completely, but if you can slow it down, spread out its energy, and buy people even a little more time, you can save lives. A seawall that stretches 400 kilometers can never be completely solid. It has to cross rivers. It has to leave room for roads, harbors, and places where people need to get through. Every opening creates a potential weak spot. The video says there are about 443 floodgates built into the system, and every one of them has one job: close before the tsunami gets there. That's why Japan didn't rely on people to do it manually. The moment an earthquake is detected, seismic sensors automatically trigger the gates. In many locations, giant steel doors begin closing immediately, without waiting for anyone to push a button. Some of those gates don't even depend on electricity. They use gravity to bring the steel curtain down. So even if the power goes out after a major earthquake, the gates can still close. What impressed me even more was how seriously they treated the smallest details. Every gate was tested under pressure, beyond its normal design limits. If inspectors found a gap only a few millimeters wide, it had to be fixed and tested again. A tiny opening might not look like much, but under the force of a tsunami, that small leak could quickly turn into a much bigger problem. Nothing was left to chance. Every floodgate, every sensor, and every warning system is connected to one central control room. The entire network is monitored together, and Japan runs emergency drills every March 11 to make sure the system is ready. The wall also keeps checking on itself. Sensors constantly monitor settlement, movement, cracks, earthquake performance, and the condition of every floodgate. Engineers don't just build it and walk away. They keep watching it long after construction is finished. And that's probably the biggest takeaway from all of this. This isn't just a giant wall made of concrete. It's a living system built to detect danger, respond immediately, and close its weakest points before the wave ever reaches the shore. After the entire system was finished, it faced a real test. A magnitude 7.4 earthquake struck. The sensors activated, and all of the floodgates began closing just as they were designed to. According to the video, engineers found no major cracks and no significant movement in the tetrapods after the quake. For a project this massive, that was an incredible result. But here's the part that stayed with me. None of that means people can stand behind the wall and feel completely safe. From the very beginning, this seawall was never designed to guarantee that it could stop another tsunami as powerful as the one in 2011. Even the engineers knew that. Those stairways built into the wall aren't there for the view. They're emergency evacuation routes, carefully planned so people can reach higher ground as quickly as possible. Today, people walk along the top of the wall. They jog there, ride bikes, walk their dogs. It feels like part of everyday life. But it's also a quiet reminder of why the wall exists. The wall can slow the water down. The sensors can close the gates. The engineering can buy precious time. But in the end, the most important decision still belongs to the people. When the warning comes, getting to higher ground is still the strongest defense anyone has. Maybe that's the biggest lesson Japan learned. No wall is stronger than people who are prepared before disaster strikes.